Something like that. Kind of
All right, guys, welcome to Sea Level Rise in Society. We have our guest lecturer today. We have Hal Needham. He is the director of the Center for Coastal Heritage and Resiliency, and he is a hurricane expert. He's created a database called USurge that's really awesome. I can share with you guys. And he also worked at LSU previously. This is his brand new job. What is it, 2 weeks at the Galveston Historic Foundation. And before that he was at LSU, he was the program director for a program called SKIP. So we're really excited to have Hal here. Oh, and here comes Jay. So Jay's gonna speak next. So I'll introduce him after Hal. So we can get started. Thanks.
Hey, Karen. Hey, everybody. Thanks for the intro. I'm really excited to be here today, and thanks for inviting me to be a part of your class. Karen, I just tried to share my screen again, and it said my internet is unstable, of all things. I'm going to try here again.
Your screen.
You can see the screen?
Yeah.
Okay, then that's strange. So can you see, is that filling the screen right now?
No. At the bottom, you can press start slideshow, play from start.
Play. Yeah, that's what I did. Does it? On my screen, it just shows like the intro slide. Can you see that?
Yeah. We see the intro slide, but we see everything around it. That's okay.
Oh, you do?
Yeah.
It said sharing is paused. Bring your shared window to the front. Hang on 1 second. Is that better now?
Yeah.
Okay, cool. Well, thanks everyone. I'm really excited to share with you about storm surge, and we're going to talk about how that ties into sea level rise and everything. So, as Karen had mentioned, I'm here in Galveston, Texas, and Galveston's actually an interesting place to start a storm surge conversation because in the late 1800s, Galveston was actually one of the wealthiest cities per capita in the United States. So this was a very wealthy port, a lot of commerce. And what's that?
Can you mute us, maybe?
Oh, can I mute you? Let me see.
Oh, I'll mute us. I'll mute us. It's good. It's good. Sorry. Go.
Is that okay? So, yeah. So Galveston was a very wealthy port city. In fact, per capita, I think it was the second wealthiest city in the United States. When you drive around today, you still see a lot of evidence of the glory days of Galveston. It's still a wonderful place to be, but you know, back in the day, there was a lot of great Victorian architecture all throughout the town. Unfortunately, in September of 1900, they didn't know it, but a Category 4 hurricane was approaching. This is a depiction of the storm surge, which started on the day of September 8th. That night, the storm surge got so severe, it actually destroyed much of the town. So where I'm talking to you from right now is right around this part of the town right here. So this is showing a map of the town. On the south here is the Gulf of Mexico. On the north is Galveston Bay. And where you actually see this line here, this was a line of debris. So everything inside here more or less survived the storm, but everything on the outside was pretty much demolished. So I live right out here towards the beach, and that whole area, in fact, this is a photograph that was taken from my street in 1900. This is at 12th and Sealy. I live at 7th and Sealy, and my house today would be out here somewhere just in the debris. This was a 20-foot storm surge that just completely devastated most of Galveston Island. They think at least 8,000 people died. It's still the most deadly natural disaster in U.S. history. And the reason I'm starting with a lot of these slides of Galveston is just to show you, even though a city might be very wealthy and have a lot of strong fortified buildings, it's really no match for a powerful storm surge. And I just wanted to depict the force of water when it hits even big cities like New York or Tampa, Miami. Many of these cities, you know, they have big buildings, are very vulnerable to the force of water. So what is storm surge and why is it so powerful? I really like this graphic from the Bureau of Meteorology in Australia. So this shows here on the left what we call mean sea level. That's sort of the average of high and low tide. And you know, along, for example, the Gulf Coast, we have a pretty low tidal range. On the East Coast, it gets higher, especially when you get towards the Northeast, like the Mid-Atlantic coast in New England. But here we have high tide and low tide. We have mean sea level. But when we have a storm surge event from a tropical cyclone or hurricane, prolonged onshore winds actually raise the entire sea level. So when we hear about a 12-foot storm surge, that actually means the sea level is going up, rising about 12 feet. And on top of that, we have strong destructive waves, which will destroy, often anything that they hit. And so that's why storm surge is such a destructive hazard. So I started my grad studies at Louisiana State University in 2008, and I wanted to study storm surge from a climatological perspective. So really, I wanted to run statistics, find out how often extreme surges happen. And to do that, I needed storm surge data. I started looking for a storm surge database, and I found there really was none for the Gulf Coast or the Atlantic coast for the U.S. However, I found that there were many sources of storm surge data out there. So, for example, surge data were available for more than 67 sources. This was just for the U.S. Gulf Coast. There were 28 different federal government sources. There were numerous books and academic publications. And then I actually looked at historical newspaper archives for 16 cities along the Gulf Coast, and I read over 3,000 pages of newspaper, especially for the late 1800s, early 1900s. I found there were a lot of storm surge data out there, but they had never really been compiled into one place. So, for example, U.S. government data, NOAA. So NOAA, basically they support the National Weather Service, the National Hurricane Center. The National Hurricane Center has hurricane or tropical cyclone reports since 1958, and many of those reports contain storm surge or storm tide levels in the back of the reports. They had just never really been archived into a database. USGS, they've done a fantastic job of going out and deploying mobile tide gauges during hurricane events, starting with Hurricane Rita in 2005 and still going to this day. And those mobile tide gauges will often provide dozens or even more than 100 high water marks. FEMA has been doing a great job of going out and actually collecting high water marks in communities that are inundated. This is important because the highest storm surges will actually destroy the tide gauges that are there to measure water levels. But FEMA can send in teams that take high water marks in buildings, and that can give us a good idea of what's happened. And then the U.S. Army Corps, I was amazed to see some really superb data coming out of the Army Corps, even as far back as the early 1900s and the late 1800s. This is a map from South Louisiana, and this was from a hurricane that struck in 1915. The black line here is the track of the hurricane. So it came in here by Grand Isle, and actually the eye of the storm passed over the western part of New Orleans and out into Lake Pontchartrain. You probably can't read the numbers from where you are, but there are numbers all throughout this map, and those are actual high water marks that were measured. So, they didn't have cell phones or internet, but they had paper and pen and pencil and tape measures, and they could go out and actually measure these high water marks. Incidentally, everything that's shaded in gray here was inundated with salt water. That's just a tremendous amount of real estate that was flooded by the storm surge in 1915. And so, again, these maps were just sitting in the library, and we thought we'd bring them to the modern age and digitize them and bring them into a data set. So, again, we saw that there were plenty of data to build a data set, and we thought, perhaps we could name this water height observation data or something like that. However, we thought if we do a really high-profile project that gets a lot of notoriety, we need to have a good acronym. And the problem with water height observation data is that no matter how you really try to do the acronym, you end up with FUDAT, which I don't know if you've heard of that before, but that's really the battle cry for the New Orleans Saints football team. So, I didn't see a problem with this. I thought, the people sending us money are up in DC. They never heard of FUDAT before. So I thought we could just call it the FUDAT database. And then in our annual report, we could show a bunch of pictures like this. And, the people up in DC would say, we don't really know what they're doing down there in Louisiana, but people seem to love water height observation data. We'll just keep sending them money. So that was kind of my plan, but I was overruled. I didn't make all the decisions. So the initial data set that we created actually was called SurgeDat. So this was tropical cyclone generated storm surges. So we're looking at hurricanes and tropical storms from 1880 to present. So that's 136 years of data. And now we actually have over 9,000 high water marks in the data set. And these come from 350 unique tropical cyclones. So those are, named hurricanes and tropical storms for the US, as well as an additional 350 tropical cyclones around the world. Most of the global big surges happen in the northern Indian Ocean around the Bay of Bengal, including countries like India and Bangladesh. In East Asia, like the Philippines, China, and Japan. And then we also see a lot of big surges. Well, I shouldn't say a lot. Occasionally, there have been some pretty substantial surges in Australia and to a lesser extent in Oceania, like the South Pacific Islands. But they have issues of storm surge inundating entire islands and wiping out their food supply and water supply. So again, this is SurgeStat. This is something that I really worked on for my master's degree and PhD at LSU. And this is a snapshot of what we found when I built this for the Gulf of Mexico. What you see here is every circle on this map is a unique storm surge event. The larger, darker circles are higher magnitude surges. So where you have red circles, you have a surge more than 13 feet or 4 meters. Where you have purple circles, the surges are more than 16.5 feet or 5 meters. And the big picture we see here is we see a lot of purple and red circles from around Panama City, Florida, throughout the western part of the Florida Panhandle, across Alabama, Mississippi, Louisiana, and Texas. And we also see some of them here in extreme South Florida and the Florida Keys. But if you notice from around, say, Fort Myers, Naples, up through Tampa, Sarasota, Tampa, Cedar Key, and even over through Apalachicola, at least since 1880, we have not seen storm surges that exceeded 13 feet, which is really interesting when we see the numerous number of storm surges in other parts of the basin. And we think that there's a reason to this, and this has to do with the factors that cause storm surge inundation. And I believe for your class you had read a chapter that I had been the lead author on, and I talked about a lot of these different factors. So actually going through these, we have storm factors and coastal factors. So storm factors are, for example, maximum sustained winds, storm size, and forward speed, as well as I should mention the storm track. And let's go back here. If you talk to someone in the Tampa area, they'll say, oh yeah, we've seen a lot of hurricanes, but a lot of the high profile hurricanes that we've heard of that have struck Florida, like, Andrew, or even, well, Betsy was farther south, but say Katrina, that's high profile storm that came into the northern Gulf Coast. A lot of these storms strike the east coast of Florida. They move across the peninsula from east to west. When they're entering the Gulf of Mexico, the strongest winds are blowing offshore, north of the storm center, up around maybe Sarasota or Tampa. There's a wraparound wind that might produce a 5 or 6 foot storm surge around Naples or Fort Myers, but it's not really this substantial storm surge. Then these storms often get into the Gulf of Mexico, and then they'll move over open water for maybe 48 or 60 hours, just pushing a lot of energy and momentum, and just push a lot of water into the northern and western Gulf Coast. So storm track has something to do with it. Also on this list here, we see coastal factors such as bathymetry, which is your offshore water depth, your coastal shape, and your coastal aspect, or the direction your coastline is facing. And so just to talk about that briefly, what we talk about coastline shape, this coast of Louisiana here juts out almost into a right angle. If you have a hurricane centered along the, in the center of the Gulf of Mexico, it's producing sustained winds coming from east to west. That piles up a lot of water here east of the Mississippi River. And bathymetry was one of those factors that I had mentioned in the list. It's a little bit counterintuitive. Actually, where you have more shallow water offshore, the surge tends to be higher because you're moving a lot of water into a small container, so to speak. And so that's one of the reasons why the highest 2 storm surges along the Gulf Coast, or even in the United States history, have both happened here in coastal Mississippi, close to Pass Christian. Hurricane Camille produced a storm surge close to 25 feet, and Camille in 1969, that was around 25 feet. Katrina was around 28 feet in 2005, and they both produced their peak surges in roughly the same location. And again, that's because this coastline juts out here at a right angle, and this water is very shallow off the shore of Mississippi. So there's a reason why we tend to see more storm surges or higher storm surges in some locations compared to others. So it's not just completely random, there really is a pattern to it. One of the big limitations of this work that I had done for my master's degree is that every storm surge is depicted by one symbol on the map. For example, Hurricane Ike produced the highest storm surge here in coastal Texas, around 17.5 feet. But Ike actually inundated the entire northern Gulf Coast from Texas to Florida. So what I started doing in 2012 was leading a team of students at LSU to create maps where we actually look at the storm track. So this is Ike here in 2008. You can actually see this track of the storm with hourly position and intensity. And you can also see these symbols here which show the highest watermark. So this is either from storm surge or storm tide. The darker colors are higher magnitude or higher water levels. We see here in coastal Texas over 16 feet of storm surge. But this is amazing. When you move more than 250 miles east of the storm track, we still see storm surge higher than 8 feet south of New Orleans, even though it's maybe 250 miles away. So that just shows you really the extent of storm surge from Hurricane Ike. We started doing these for all storms that had struck the Atlantic and the Gulf Coast, plotting out the track of the hurricane and all the observations. And once we did that, we realized we could overlay these observations into a computer system that's, if you've heard of GIS or Geographic Information Systems, we populated a GIS with these data, and we created an experimental web tool where we could go in here to, for example, Galveston, where I am now. I selected a buffer of 10 miles, and this program returned all of the observations within that 10-mile buffer. Then on the fly, this program ran statistics, and it says that on average, the 100-year storm surge near Galveston is around 17 feet. The 50-year storm surge is around 14 feet. And when we say a 50-year storm, that just means on average we should expect to observe a storm of that magnitude or greater every 50 years. And so, again, this is just using data since 1900 for this process. This didn't really use any modeling. It was just very data-driven. I do want to say one last thing, too, about this. This slide here is all based on observations since 1880. Models will tell us that if a hurricane moved in here from the southwest and made landfall north of Tampa, we could see a 20-foot storm surge in Tampa Bay. It just has not happened since 1880. That would be a more rare track, but it certainly could happen. And that's really the limitation of data work, is that we haven't seen all possible scenarios since 1880. Hurricanes are very rare extreme events, and a given location might only experience a certain track maybe every few hundred years. And so this shows us what has happened in the past 135 years, but not everything that can happen. This, again, was a program that we developed to actually extract that data by location. And then for a place like Galveston, what we did was we built these histograms, and even though I'm talking about Galveston, a histogram for, say, Miami may look a little bit different, but there'd be one or two things that are the same, and there's a general principle to these. What I've done here is I've plotted out, for Galveston, I have high water marks for 72 hurricanes and tropical storms. I've ranked them. Number one rank is the highest. That was the 1900 storm. It was a 20-foot storm surge. Number two was in 1915. It's 15.5 feet. But if you notice, when we go to the smaller events, they don't change very much from one rank to the next. The difference between storm number 51 and 52 just might be an inch or two of storm surge difference. But when we get out here to the more rare events, the top couple events are much higher than all the others. That's a very common pattern that we see in extreme value analysis. The highest event or two tend to be much higher than the others. So we can see this in other things like financial data or health data or even sports. Here's an example from sports. I took the 100 highest NFL passing leaders of all time. I ranked them from 1 to 100, and I plotted out the total number of yards they've passed for in their career. And what we see here is there's not a lot of difference between number 79 and 80, but when we move up here to the top three, they're much higher than the others. And so really that has to do with the frequency of extreme events. A quarterback number 87, this is an extremely good quarterback, maybe was the star of the college team, got to the NFL, even made the top 100. But we might see a quarterback like that come along maybe every year or maybe two per year. These quarterbacks like this, like a Brett Favre or a Peyton Manning, they might only come along every 10 years or 12 years. They're much more rare, and they outperform the others by a really healthy margin. So this is just a common pattern with extreme statistics. And for these storm surges, we're really concerned about the extreme events, not really looking at the average events, if you will. So again, this is just an example to show that this is a common thing in extreme statistics. The concern for a place like Galveston, I've gone back to these highest 72 events. What I did here was I shaded everything that's happened in the last 50 years is shaded in blue. And so if say you're 60 years old and you moved here when you were 10, and you say, okay, I've seen a lot of weather in Galveston, I get an idea about how bad the storm surges can be. Mostly what you've seen is these low magnitude events, 2 feet, 3 feet. You've seen a few of these events between 5 and 10 feet. And Hurricane Ike, which hit 6 years ago, or no, it's 8 years ago, in 2008, that was a 12.5-foot surge. If you were in Galveston, you would probably think that that was a real outlier. That's about as bad as it can get. However, what you might not realize is the 1900 storm produced a storm surge almost twice as high as that. So the concern is that as humans, we might think 20 or 30 years is a long time. We have a lot of memory, or even 50 years. But in the scheme of things, as far as the natural world, these really big events that are much higher than the others, they might only come along every 100 or 200 years. And so that's why it's so important that we go back and look at the history. Even if we had 50 years of knowledge, we might be shocked to see a storm surge to be twice as high as what's happened in the last 50 years. So that's really sobering, but it's important when we plan out coastal engineering, coastal planning, evacuations, things like this. It's important to have these records along as well. So this is a storm surge I saw in New Jersey, of all places, in early October. This was Hurricane Joaquin was down in the Bahamas. There was a strong high pressure over eastern Canada, and they just had a prolonged onshore wind for 4 days, which really put some storm surge over the seawall here. And you know, I've always been interested to look at statistically, how often does this type of thing happen? Does this kind of thing happen every year, or every 10 years, every 20 years? So what I did a lot of my PhD was looking at statistics of extreme storm surges. I'm not going to really get into too many details. 3 common, or really I should say emerging practices of looking at this type of information is using extreme value theory, also looking at log linear plotting, and that's actually what I use for a lot of my PhD. And then a third method is called Bayesian inference, which really considers quantifying your level of uncertainty. And that's the thing. People might say Katrina was a 200-year event, or Katrina was a 500-year event. The reality is nobody actually knows. As we bring models and data together, we can start to get a better idea of how certain or uncertain we are of something, and that's where Bayesian inference can come into play. I'm going to show you a quick example of log linear plotting from my PhD. What I did here was I took data from Bay St. Louis, Mississippi. I took 115 years of data from 1900 to 2014, and this is in meters here. This is the magnitude of the storm surge event. And basically, Katrina was the highest event in 115 years, so I just went to 115, and I plotted Katrina here at 8.5 meters. Camille was the second highest event in 115 years, so just with division, that comes out to a 57.5-year event. And I'm sorry, this was Katrina here. This is Camille from 1969 here. This is 7.5 meters, the second highest event. And so all of these blue diamonds are actual events, and I just ran a line of a regression line through here. I should mention as well, this x-axis is logarithmic, the y-axis is linear, and so I just got a line of best fit, and you can see the 100-year storm surge comes out to right around 8 meters, or about 25 feet. I did this for 26 locations along the Gulf Coast, and I created this map as part of my dissertation. There's a lot of information here, but it's really not too complex. I did this for 26 locations along the Gulf Coast. The top, you can see here, these are in meters here, the y-axis. We go up to 12 meters. The top of the highest blue bar is the 500-year storm surge level. Where the shading changes, we go to 200 years, then 100, 50, 25, and 10. And these red dots are the actual observations that make up that distribution. The big picture here is we have a lot of variability depending where we are. The coast of Mississippi here, so this is city 16 here, Bay St. Louis. I just showed you a graph for that city. Hurricane Katrina produced about an 8.5 meter storm surge. So that's this red dot here. And according to this graphic, that's maybe a 140-year event. This is Hurricane Camille, which was less than a 100-year event. We've had 2 of those in the past, 50 years or so. And so this is also Katrina here at City 17. This is also Camille. And we can see that this area here in coastal Mississippi, as well as some of these bays in Texas, like city number 6, Baytown, city number 3, Matagorda Bay area by Port Lavaca, those have some really extraordinary high water levels. Whereas locations like along the west coast of Florida, the water levels tend to be much lower. And we haven't really seen in some of these cities storm surges higher than 3 meters or around 10 feet since 1900. So it just shows there's a lot of variability. This doesn't necessarily depend on how many hurricane strikes you've had. Again, these areas like coastal Mississippi, you can have a hurricane strike out here in Louisiana and you're still going to get a big surge in Mississippi. So this was just a snapshot. We think that this could be useful for planning and things like that, coastal engineering. Again, a lot of variability depending on where you are. This research will impact many industries like fishing and seafood, beaches and resorts, coastal development, oil and gas industry. So, these storm surges cause a lot of damage and they're really high profile events. Finally, I wanted to talk about sea level rise and storm surge. I know you guys have been talking a lot about sea level rise, and so it's interesting. I would consider these 2 hazards almost like cousins, right? I mean, they're related, but they're also different. So this is a photograph of Laplace, Louisiana, on the western end of Lake Pontchartrain in 2012 when Hurricane Isaac hit. And this area actually extensively flooded. Over 4,000 people needed to be evacuated. Here are some more pictures of Hurricane Isaac in Laplace. The reason this is fascinating is this is right on the edge of Lake Pontchartrain, not far from New Orleans, but this area really did not flood in Hurricane Katrina. So Katrina comes along with this huge storm surge, the highest surge in the history of the Western Hemisphere, did not flood this location near New Orleans. But Isaac comes along barely a Category 1 and floods this location. Many people were just shocked. I mean, this was barely a Cat 1, and we're seeing water everywhere in these communities. How did that happen? Well, Isaac was really stationary here south of the Mississippi River, and it was a large storm, and it was just pumping a lot of water into Lake Pontchartrain. Laplace, that city I showed you, is right out in here. But what happened was the level of Lake Pontchartrain was elevated 5-6 feet above sea level for around, I think, about 60 hours or so. So that's 2.5 days. And so at the same time, there was 12, 13 inches of rain out here. And that rain, I mean, generally rainfall drains through gravity-fed system. It requires a slope to run downhill. But when the lake is elevated 5-6 feet above normal, where's the water going to go? The lake level is just as high as the town. And so what happened was these areas just could simply not drain. Areas close to New Orleans did not flood in Katrina, got flooded really bad in Hurricane Isaac. So you may have seen some of these depictions. This is showing the coast of Louisiana and what may happen with a 1 meter sea level rise. This was produced by Weiss and Overpeck at University of Arizona. Don't get scared with this next one. We're going to take it home to South Florida. This is looking at 6 meters, so that's a lot more. But again, the red area supposedly could be inundated with 6 meters of sea level rise. I would just want to pose this idea to you. I often used to look at these maps, and I didn't really think about a process that's going to happen to go from where we are now to what may happen in the future. I mean, sometimes we may think that just one day, if you live out there by Lake Okeechobee or Daytona Beach or somewhere, you're just going to wake up in the morning, get your coffee, look out the kitchen window, and you're going to say, my goodness, there's the ocean. It just, okay, there it is. It made it. But that's not really how it's going to happen. What's really going to happen is, this location I just showed you here is in the red area that will be affected probably by a meter of sea level rise. But right now, 364 days a year, that area is dry. But in the extreme events, in the hurricanes, all of a sudden, we have a lot of rainfall, we have a lot of storm surge, and because we have sea level rise, again, the 12 inches of rainfall, it could not drain that well, mostly because of the storm surge, but the sea level rise now is even retarding that rainfall runoff as well. So this is where sea level rise is going to make these extreme events even more catastrophic. And so over time, these areas in red, they're not just going to go from dry to wet one day. It's going to happen in the extreme events, happening once every 5 years and once every year, then maybe several times per year until they're wet permanently. So finally, I want to wrap up with USurge. This is a project I've been doing just in the past 3 months or so. If you remember, I talked about this, the storm surge database, which I love. It's great. There's tons of storm surge data from around the world. However, I noticed as I traveled around and talked to people that want to use these data in the real world, everybody wants information that's very localized, right? So they say, I want information just for Tampa, or just for Palm Beach or Miami or Savannah, Georgia. And so what I started doing was taking these data and information and making them very localized. And so if you go to www.usurge.com, you can actually see these pages. I'm trying to launch 1 or 2 per month. If you go to South Padre Island, Texas, it'll give you an overview of the island. It will also give you an overview of storm surge history in that area. And then I also am posting graphics as well. So this is a graphic of a histogram for all of the storm surges that we've observed at South Padre Island. There have been 38 since 1880. And then this is a time series as well. Be careful with these time series. We see a lot of data in the more recent, so this is going from 1880 to 2020. We see a lot of low magnitude surges more recently. If you ran a trend line through this, it would look like we're seeing decreasing magnitudes of storm surge, but that's not really accurate. This is mostly, it's climatology, but it's also, we have a lot more tide gauge data from the past 15 years. And so we're getting more accurate data over time. So you have to be careful of that when you do analysis. But I think it's interesting to look at the biggest storm surges that have happened if you're a planner or working in coastal engineering. You can also go to videos. So Hurricane Ike really flooded most of the Gulf Coast. And these are videos of Ike action in that location in South Padre Island. So I'm going to have videos and pictures where you can actually see what a 3-foot or a 7-foot storm surge looks like on the landscape. So that's everything I have. I hope I didn't ramble too much there, but I don't know if we have any time for any interaction or questions, or Jay, if you're going to go right away. But I'm going to. Well, actually, Karen, maybe you could unmute your end there, and I'd love to interact with you guys.
Yeah, we're going to have Jay go next.
Okay, awesome. I'll mute my end here.
Yeah, Jay, can you unmute? Do you see how to unmute? That was amazing, Hal. Wait, let's clap for Hal.
Okay. Karen, I can't see how to unmute mine. Should I stop the share or should I?
Yeah, stop the share.
Okay, I stopped the share. Oh, okay, I see how I can mute.
If you hover towards the bottom of the camera.
Yeah, I got it. Thank you.
Jay, do you see the share screen in green?
Yes, I do. Thank you, Karen. Oh boy, let's see. Give me just a second to find.
I must say, Jay, you have a much nicer office than I do.
Well, I'm actually at home, Hal.
You're embarrassing me.
But I'm having trouble finding my share screen. Let's see.
If you hover towards the bottom of your picture.
Well, I hit that, and now I have a window. Select a window or an application, but I don't see my PowerPoint.
You can share your whole screen.
Let's see what happens when I do this. No.
Yeah, I think you're good. Okay, so now pull up the PowerPoint on your screen.
Okay, all right. We're getting there. All right.
Oh, wow.
Are we in business now? Well, first let me say thank you, Karen. Thank you, Hal, for the presentation. I really enjoyed the work you're doing, and it was a great look at storm surge history. And what I'm going to be doing is talking about sort of our hurricane history in general. When Karen and I first talked about this presentation, I had to think about how I wanted to convey the information for this particular group, because my background and my work is about history. I'm not a meteorologist. I'm not even a weather scientist. I'm more of a historian who has spent probably the last 20 or so years collecting a lot of information about hurricanes, particularly in North Carolina and in Florida. So let's just go ahead and get into that. And I am from North Carolina. I'm living in Raleigh now, but I grew up on the North Carolina coast and spent pretty much all of my life along the North Carolina coast on the southern Outer Banks. And growing up, I learned a lot about hurricanes. And by the way, North Carolina ranks third in the nation in hurricane landfalls, not surprisingly, after Florida, #1, and Texas is second, and North Carolina ranks third. So, as I said, a lot of what I have done over the years is to spend a lot of nights and weekends in libraries and in museums and researching some of the history of hurricanes that have affected us all through the years. And in particular, I'm going to focus on some stories from the books. I've got one on Hazel, one on Floyd, but most of the work was in putting together Florida's hurricane history and North Carolina's hurricane history. The Florida book is in its second edition and is available through UNC Press, and North Carolina's hurricane history was my first book. That's now in its fourth edition. That's one of the issues with doing hurricane research is, you write a history book and then more storms keep coming. So I created a little cottage industry for myself, I guess. A lot of the research that I do involves hard data, some of the same kind of digging that Hal has done and looking through the hurricane records, but also I'm interested in the photographs. And my books are chock full of hurricane images that try to tell the story about the storms. And of course, the farther back in time you go, just like the data, the farther back in time you go, the harder it is to find good hurricane images. Because for one thing, in a lot of these areas, people during a hurricane or even after a hurricane, they were way too busy to stop and take pictures unless you happen to find an archive from a news agency of some kind. So we'll talk about some of those. And I was going to add that Hurricane Hazel in 1954 made landfall in North Carolina as a Cat 4, the most powerful storm we've ever had. In fact, it's the northernmost Category 4 to hit the East Coast. And it's a storm that old-timers here around in North Carolina still talk about. I grew up hearing stories about it. It came through before I was born, but as a child, I heard story after story of Hurricane Hazel because my hometown of Southport, North Carolina, was pretty much ground zero. I'll refer back to Hurricane Hazel a little bit later, but it's one of those iconic storms. Every generation has one for any particular locale. If you live in Miami, or if you've lived in Miami for a number of years or decades, no doubt you have lots of Andrew stories. Those people that suffered through Sandy and Katrina and all the others, and just as Hal said, storms like Ike. These are storms that create memories. In a lot of cases, the stories that make up my book are told from one generation to the next. There's a lot of that sort of oral history that's passed along from grandfather to son to grandson and so forth. And so I wanted to try to capture that a lot with my book. So Hurricane Hazel was the storm that really got my attention and piqued my interest when I was coming along. And as I said, Southport was the sort of a little bit to the east of landfall, which gave us the highest storm surge and the highest winds in that particular area. So when I do my presentations, most of the time I'm talking specifically about Florida storms or I'm talking about North Carolina storms. But today I decided to blend the two and share with you some insights into why I think looking at this history is important. And I begin with Christopher Columbus. It seems a little strange to say this, but Christopher Columbus discovered hurricanes, much in the way he discovered the New World. Of course, he didn't discover them, but he was the first European to write about them. And in fact, it wasn't until his fourth voyage to the New World that he encountered a tropical storm, which he didn't understand. He didn't understand the cyclonic nature of the storm. He just thought that part of the Western Atlantic was a very dangerous part, and in the future trips that he made, he avoided that particular area. So it all began with Christopher Columbus, but I thought I would add that the actual the Native American population, the indigenous people who were here before Columbus, certainly had lots and lots of experience with tropical weather. In fact, the very word hurricane is derived from the Mayan term huracan, which was their storm god. So if you go through my books, you'll find that a lot of the stories that I've collected, mostly gathered by historians that preceded myself, they really trace that history all through the colonial period, from Columbus through the 1500s, the 1600s, and all the way up into the 19th century. Most of those records are, I would say, they're spotty at best. We don't know the details. In other words, we don't know how many Cat 4 storms we had. We don't know if we had Category 1 or Category 4 for a particular storm, because it might just be described in a historical journal as a loathsome gale. So that's all the information we might have. But we do know very often how many ships went down, what the impact was particularly along the North Carolina coast, which has been labeled the graveyard of the Atlantic. There are about 3,000 wrecks off the North Carolina coast. Many of them went down in the 19th century. Many of them went down during tropical storms and hurricanes. And it's interesting, as you go back and look through some of those 19th century storms, we may not have really good data, but if we can look and see that this particular hurricane sank 37 vessels, from one end of the state to the other, then we have a pretty good idea that this was a pretty serious and powerful storm. So I know you've all heard this quote before, but it's been used many times, but it really is true in the context of hurricanes. Those who cannot remember the past are condemned to repeat it. So what I've prepared for you today are just some quick anecdotes and a few snapshots, if you will, from my books that talk about the importance of this history. And what I've done is I've put together sort of 10 lessons learned. And so bear with me as I go through these, and I'm going to jump around a little bit. And this is probably an evolving program. Karen, maybe the next time I do it, it'll be a little more complete. But the first one is records were made to be broken. And that's sort of the, kind of goes without saying. We know, as Hal said, we have a very small sample period for our research. Our research into hurricane history, I think Hal mentioned, started in 1880. A lot of the records I have go back to the 1850s. But it doesn't matter. That's a very small sample period. It's less than 200 years. And if you talk to a geologist about a 200-year period, for example, they'll look at you funny, because that's really not enough of a time period to make broad assumptions. So we know that as we accumulate records, they're going to be broken. Let's take the Labor Day storm of 1935, which was Category 5, made landfall in the Keys, devastating in the Keys, and then up the west coast of Florida. One of the things that happened during that particular storm was, or prior to the storm, was the bonus marchers. These were World War I vets, were sent down to the Keys to help build the Flagler Overseas Highway. And they were in the process of constructing this project. They were given jobs by the federal government. This was, again, pretty much right during the height of the Great Depression, and they were stationed at the Keys to build these. Well, you may have heard the story. As this storm approached, there was some warning from the Weather Bureau that the storm was coming, and so they called for a train to come and evacuate these troops, but the train arrived too late. There were hundreds of fatalities as the train was washed off the tracks by a very significant storm surge. I think it was in the range of 17 to 19 feet. It was a great American tragedy, and it was, by the way, the lowest barometric pressure ever recorded at that time. And the barometer that was used in this particular event was, the measurement was made, I believe, on Long Key, and it was measured in 26.4 inches on this particular barometer. And this was made by a gentleman who had some experience. He was a veteran tracker, and he very carefully marked his barometer and submitted it to the Weather Bureau office in Miami. And after doing some calibration testing, they realized that it was an accurate reading. It actually was lower. It was 26.38 inches of mercury. So as this report was transmitted to Washington, there was complete disbelief. No one in Washington believed there could possibly be a barometric pressure that low. They insisted that the barometer was obviously not calibrated correctly, and they requested that it be shipped to them, and it was to Washington. And after about 2 weeks, they learned that it was, in fact, incorrect. The barometer true reading was 26.35 inches of mercury, which stood as the lowest barometric pressure recorded in the Western Hemisphere until modern times. So it's just one example of how, as we look at every record, it doesn't matter if it's a storm surge, a wind record, a dollar estimate, a death toll, there's always the next storm to consider. Now, here in North Carolina, a friend of mine has a drugstore in a little town called Belhaven, probably about, about midway up the North Carolina coast. And in his drugstore, there's a pole which the employees have been making marks on with every flood since the early 1990s. And it's just sort of interesting to me that this is one of those watermark episodes that you want to try to look for these, and particularly if you're doing the kind of work that Hal does. You can see that this is a meter stick that's next to the pole here. So you're looking at Irene in 2011 as the highest of this group. But it's just another example of how, as time goes by, we can expect that, that the records from the past are going to be broken. Now, we also can see that storms have become less deadly, but more costly. And I'm looking at, again, this historical period, particularly over the last century or so. And some of the great hurricane disasters in terms of fatalities are on the chart here. Hal talked at length about the Galveston storm. I have read estimates as many as 15,000 lives might have been lost, but the more conservative estimate would be 8 to 10. The Okeechobee hurricane in 1928, conservative estimate there, again, 2,000 to 2,500 lives. And then two storms in 1893, each of which claimed 2,000 lives, and then Katrina. Now, the Katrina figure, I will put a little asterisk there, that's a slippery figure because everyone has a different total fatality count. You can ask FEMA or the Hurricane Center or different emergency management groups, and sometimes they'll give you different numbers. But this was the number that was presented from NOAA shortly after the storm. So what we see, though, is that most of the storms on this record were long ago, and it was a time when warning and evacuations were poorly done or not done at all. Hurricane Katrina impacting a major metropolitan area is no surprise. Now, this is, unfortunately, my charts need to be updated because I've sort of grabbed these, but this is looking at insured losses in the hurricanes that we've had just from 1970 up through hurricanes Katrina, Rita, and Wilma in 2005. So you can sort of see what the trend line is here. Our hurricanes are becoming more costly. This is another chart that's through 2005, again, looking at worldwide hurricanes and typhoons by decade. We're seeing more dollar damages, and it's not a surprise. It's because we have greater population in harm's way, but there's more to it than that. We also have the growth of wealth, and Chris Lancy, who is at the National Hurricane Center, does a normalized review of hurricanes every few years, and it does a great job of explaining that not only do you see coastal populations increasing, you see the amount of development increasing, but as we become a more wealthy nation, certainly we have since 1900 until 2016, we have more expensive things to be destroyed by storm surge and wind. Another example of how this plays out is here in North Carolina. In 1996, we had Hurricanes Bertha and Fran, which brought a new record in dollar damages to our state. $5.2 billion was the dollar damage for those storms in 96, completely blowing out of the water all previous records for our state. But then just 3 years later, that was topped by Hurricane Floyd in 1999. So there's no question but that it doesn't matter how extreme, almost it seems, the record might be, there's always that opportunity that the next storm comes along might surpass the other one. And there are also a lot of other economic factors. I've got a presentation that I do that I'll just touch on a little bit today, and it's all about the economics of hurricanes and their impact and their historical impact in the United States. This is you can guess what this is. This is an oil derrick in the Gulf of Mexico that was damaged. I believe this might have been Hurricane Ike. And so, you know, we don't often get to look at this kind of thing because I don't think the oil industry is particularly interested in showing it to us. But if you look at the placement, and I'm thinking about some of these maps, Hal, that you had earlier, the placement of oil derricks along the upper Gulf Coast, you can see that not only do we have vulnerability with regard to their operation, because almost every single one of those yellow dots, which represents a derrick, would be shut down with an approaching hurricane. But in the case of some of our recent storms, we actually had a supply line shut down. We had shortages of petroleum in the pipelines that flow out of the region because of the delay and the magnitude of storm like Katrina, Ike, and others. So there are all kinds of, I guess you could say, not exactly extraneous, but they're certainly tangent economic issues that result from hurricane activity. And then when you really all comes home, we have to recognize that for the individual whose home has been flooded, they may not have flood insurance, or the roof is blown off their house, there has always been a persistent expectation that somehow the government was going to come in and fix things. And that's really not the case. I think that the folks in the federal government and the Congress and others, they certainly expend billions of dollars annually, and much of it goes to mitigation, much of it goes for the recovery effort after a storm. But for every single individual to have everything put back, expecting their insurance to pay for it, or the state, or the local government, or the federal government to cover their losses, very often you find that it just doesn't happen. Yet every politician makes their case. As they experience a storm in their state, they're going to head to Washington and argue for the best response that they can. So there's a tangled web of economic factors that are at play with every hurricane disaster. And as we continue to see these multi-billion-dollar disasters like Katrina and Sandy, it has really powerful implications for our country in terms of what to expect with the next great storm. Now back to back to deaths for a second. The fatality count, as I mentioned earlier, has generally been trending downward. But it doesn't mean that we can't have a catastrophic, deadly hurricane. We saw Katrina's death toll of over 1,800 lives lost. One of the things that has been a real priority for FEMA and for state emergency management planners to get the word out about is that the single most dangerous thing you can do during or after a hurricane event is to drive your vehicle on a flooded road. During Hurricane Floyd, we had 52 fatalities in North Carolina. 28 of those were people who got in their four-wheel drive vehicles or their trucks or their Jeeps. They thought they could navigate down some flooded roads. Maybe the water was only a couple of feet deep, but they were not able to get through it because the swift current pushed their truck over into the ditch, flipped it over, and they drowned. And it is probably the single most important lesson to be learned about the risks of a hurricane. The third one is you don't need to be at the coast to get slammed. And this is probably not as evident in Florida because I think no part of Florida is more than about 75 miles from a coast. But if here in North Carolina, it certainly is the case because some of our great hurricane disasters haven't really been down at the beach. They very often are in inland areas. In our state, you look at places like Raleigh and Rocky Mount and Greenville, Charlotte, Fayetteville, inland cities that are maybe in some cases hundreds of miles from the point of landfall. And they suffer too. They suffer the winds as the storm rakes through and topples trees and crushes mobile homes and so forth. But they also suffer from flooding because the river systems across the south from Texas to Louisiana and Alabama, Mississippi, Florida, Georgia, South Carolina, North Carolina, into Virginia, and all through the Northeast. These river systems, in many cases, they're just not designed to handle the intense rainwaters that fall with some hurricanes. Some hurricanes are wetter than others, but we have seen catastrophic flooding in a number of cases. And for example, let's look at 1916. If you look at this photograph, this is in North Carolina, but it's not at the coast. If you look in the background there, you'll see that's the Blue Ridge Mountains. This is Asheville, North Carolina, many, many miles, I guess probably 300 miles from the coast. And this is the flooding of the French Broad River. The French Broad River normally is a very placid river that flows through the center of town, but this particular event was caused by two different tropical systems, both of which one struck the panhandle of Florida, the other the Georgia coast. But as they dissipated over the Appalachian Mountains, they unleashed an incredible rain. In fact, it was 22.22 inches in 24 hours in a little town just outside of Asheville, which set a new U.S. rainfall record. So there were about 85 fatalities. There were railroads washed off their tracks. There were entire subdivisions that just slid off of mountains as a result of the flooding. So you don't have to be down at the coast. And here's another example with Hurricane Hazel, I mentioned earlier, struck North Carolina in 1954. After passing through North Carolina, Virginia, it went up through the Northeast. This is the Potomac, Washington, D.C., 100-mile-per-hour winds. Philadelphia, 100-mile-per-hour winds. When Hazel got into Canada, it arrived overnight in the middle of the night, and it created the greatest flood in Canadian history. You go to Canada today and look at or talk to their weather folks, they still talk about Hurricane Hazel as their greatest weather disaster outside of some of the great blizzards they've had. And there were, I believe, more fatalities in Canada from Hurricane Hazel than there were in the United States. So it's not always about the beachfront. It is very often the inland portions of our country that suffer as well. Now, the fourth one is you can't bet on the numbers, and as Hal does and I do, we're always interested in compiling the numbers and researching and finding out what has happened, when did it happen, and where, and for how long, and all the data points we can collect. But sometimes there are just some things that are hard to figure out. I mean, in Florida, for example, we had 10 hurricanes during more than 10. We had, in the 10 years of the 1940s, we had 12 hurricanes make landfall in Florida. And you'll see that several of these were pretty strong storms, like the September 47 was a Cat 4. So it's shocking maybe to see that much hurricane activity in such a short period of time. We had a similar situation in North Carolina during the 1950s, where we had something like 7 hurricanes make landfall in 4 years in the 1950s. And then from 1960 to 1984, a span of 24 years, North Carolina had no significant hurricane landfalls. So it makes it very difficult to make any kind of judgments about what to expect from one season to the next when you've got this kind of variation occurring. And once again, it goes back to my earlier point, our sample period is just too small. You can't really draw too many conclusions based on that. So you got to watch that. This is another interesting graphic from the 40s. You look at, these are only major hurricanes, that is Category 3 and above, from the 1941 through 1950. So you can see that Florida was certainly getting hammered there. And then there's some other cycles that have come around, 12 landfalls in 10 years. That happened from 1890 to 1899. It happened from 1941 to 1950. And then 8 landfalls in 4 years happened twice. You see the dates there. And then on 2 different occasions, in 2004 and 8 landfalls in 2 years, in 2004 and 2005. So for those of you who might remember the storms of 2004 and 2005, very, very busy time in the state of Florida. I also like to look back on some of the earlier times. This is Pensacola. Some of you probably have visited Pensacola before. You know where it is on the panhandle there. But the history of Pensacola itself is so fascinating because during the colonial period, there was a real rivalry between the French and the English and the Spaniards. They were all they were vying for new territory. They were trying to establish settlements. Whoever could establish the settlement the fastest or the first, might be able to grab a foothold in the New World. And Pensacola held the distinction of being destroyed and rebuilt 17 different times during the 1700s alone. And that was because a settlement would start to take shape. They would begin constructing some barracks and some buildings, bring in some horses and some men, and a devastating hurricane would blow through, and they would evacuate and abandon all the structures because they were swamped or washed away or blown down. And so it just gives you an example of how the recurrence. I know that Hal, when you were showing your map earlier of some of those hot spots for storm surge, as it turns out, the western end of the Florida Panhandle, the Pensacola area there and up towards Destin, it's a very much a busy space on the hurricane map. And as I mentioned earlier, in 1955, here in North Carolina, we had 3 landfalls within 6 weeks. Hurricanes Connie and Diane were only 5 days apart, followed by Ione in about 5 weeks later. 3 storms in 6 weeks making landfall on the same spot seems like such an anomaly, but then once again, you go back to the books and you can find other examples that are almost as dramatic. Now, we don't have time tonight to go into all the stories that I could share with you, but it's clear that survivors have lots of stories to tell. I'm going to just go through a couple for you quickly. Please, Karen, cut me off now or give me some warning if I'm going on too long here. The first one is a story I'd like to share about a little town called Swan Quarter.
You have plenty of time.
Okay.
We're here till 8:50.
Okay. All right. Well, I won't cut short then.
Yeah.
Let me tell you the story about this little town. It's called Swan Quarter. Swan Quarter is in eastern North Carolina. I think I got a map here somewhere. This is an old map. And let's see. I don't know if you can see my cursor, but Swan Quarter is located right here. And Swan Quarter is is now today a small fishing and agricultural community of about probably 400 people. It's not a very big town. Back in 1876, it was pretty much the same. It was a small fishing village on the Pamlico Sound, and it was probably, I guess, maybe 200 to 300 residents at that time. And in the spring of that year, there was a gentleman who was a Methodist pastor, and he wanted to build a church to establish a Methodist congregation in Swan Quarter. And he had several friends that they had been worshiping in his barn, and they realized that it really wasn't suitable. Their congregation was growing. So that spring, he and some other men from the church decided they wanted to build a new church, establish it. And so they went into sort of the heart of downtown Swan Quarter, if you will, and they knew that there was a vacant lot right on the corner of Main Street that would be a perfect spot for their church. Well, they approached the landowner, a gentleman by the name of Mr. Sadler, and they asked Mr. Sadler, would you be interested in selling your property? And Sadler, of course, he just said, no, I'm not interested. I'm keeping it for my own interests, and by the way, I don't really want to have anything to do with Methodists. So they were a little disappointed. They came back and made a second offer, and again, Sadler refused to sell. Well, they found an alternate piece of property, and that alternate piece of property was a little farther down the street and a little closer to the marsh, and there that summer they erected this modest structure, the Providence Church, and it was dedicated on a beautiful sunny Sunday morning in early September of 1876. But it turns out that very day there was a major hurricane sitting off the Georgia coast. And of course, this was 1876, so they had no way to know about it. They didn't have the internet, they didn't have phones or radios or televisions or the Weather Channel or any form of communication whatsoever. In 1876, if you lived in Swan Quarter and you were a fisherman in particular, you knew a storm was coming, perhaps by watching the wildlife and some of their behavior, but largely it was all about when the wind started to blow, the tide started to rise, you got some sense that something was happening. And that is what happened. As the storm approached, the fishermen pulled in their nets, and everyone hunkered down in their homes, and the hurricane blew through the town of Swan Quarter. And it was a pretty good storm. It brought storm surge up into the streets, and at the height of the storm, to their amazement, they looked out their window, and they saw this church that had just been dedicated, had floated up off of its foundation, and was now floating down the street. And where do you think it came to rest? But right on Mr. Sadler's property, just as they had originally planned. And so they came out of their homes, and there was a church perfectly positioned in downtown Swan Quarter. So if you visit Swan Quarter today, look for the Providence Methodist Church, moved by the hand of God on September 16th, 1876. As the legend goes, Mr. Sadler was quite impressed because he donated his land and then joined the church. At least that's the way the story is told. Another story survival story that's, there are tons of these from the Miami hurricane of 1926, which was a Cat 4 through downtown Miami. And this was at a time, the roaring 20s. Miami was a thriving real estate booming town. And there was no real warning that this storm was coming, or at least none that was heard. And so as the hurricane swept through Miami, the tides rose in the street, there were ships sunk, there were winds over 140 miles an hour. I mean, it was a devastating hurricane in Miami, needless to say. One of the stories came out of it was a gentleman who worked for the barge company there on the bay, and he was lost at sea. He unfortunately appeared to have drowned. His body was washed up, and I believe it was about a week later, his family finally was able to have a funeral service for him. And but unfortunately, they had the wrong guy, because the gentleman had survived. He had been taken in by a family and had recuperated, read in the newspaper about his own funeral, and showed up and frightened all of his family members when he walked in the door. Those kinds of stories are all over the place. There's stories about survival. Sometimes they're tragic. Sometimes they're really just gut-wrenching, and other times they're funny. But one of the most chilling stories is one told by Connie Helms. Connie and her husband were honeymooning on Long Beach the night that Hurricane Hazel made landfall. There was about a 16 to 17-foot storm surge on Oak Island when this storm came ashore. Again, a Cat 4. They had no idea the storm was coming. They had gone to bed not paying any attention to the radio or listening to weather forecasts or anything. They woke up early in the morning hearing the howling winds, and realized that this crashing noise they heard with waves breaking on the front porch of their little beach cottage. So they scrambled out the door to try to jump in Jerry's Jeep. That was her husband, and it was too late. The Jeep was flooded. By now, the water was about waist deep. And Hal, I thought this was an interesting storyline. Very often, storm surge is depicted in movies inaccurately. It's viewed as like a tsunami coming in or a single wave, but it's not. It's a rapid rise in sea level that can be in a matter of seconds or minutes. But they described with Hurricane Hazel, the storm surge, the water rose about 5 feet every 30 minutes. So in the span of a little more than an hour, it reached its peak there on Oak Island of about 15 to 17 feet. So the cottage they were in was swept away, but they had climbed into a window of this cottage next door and gone up to the second floor. They actually watched waves breaking on the rooftop of their little cottage, but they realized that this two-story structure they were in was rocking and swaying with every swell. Winds were about to peel the roof back. They knew that they couldn't stay in it. It was about to collapse. So in a moment of desperation, they grabbed a mattress off of a bed and floated out the second-story window into the storm. Connie was tied onto the mattress with a blanket, and they both just held on to each other. It was particularly frightening for Connie because she did not know how to swim. They described that, the rain was so hard and was so loud they couldn't even really communicate with each other, the wind and the rain combined. So they just held on to each other and drifted until they finally, Jerry grabbed a tree branch as he went by, and it turns out that they were in a tree top. The storm finally passed through, the waters receded, and they were about 15 feet off the ground in the top of an oak tree on the lee side of the island. They climbed down. They were able to walk something like 12 miles over the span of several hours through the muck and the mud and the dark to get back to the main highway to get back to safety. It was quite an ordeal, but they made it. They survived. They were battered and bruised, but for the most part, they were okay. And about 3 days later, they had recuperated, but they were curious. They wanted to go back out to Long Beach. They wanted to find what was left of the cottage or the Jeep. They wanted to see what was around, and when they got there, they were dumbfounded because all the structures had been washed away. 354 cottages on Long Beach were gone, and the only thing left was the beach, and occasionally an appliance here or there. The Jeep was gone. There weren't even any street signs or light poles or any points of reference. Everything was covered in sand. So they walked around for a while, and then amazingly, they found the refrigerator that had been inside their little cottage, and they recognized it. It said Westinghouse across the front. It was buried, about half buried down in the sand, and they were able to go down into, dig around the edges of it, and they popped it open, and there inside they found top of their wedding cake and a half a bottle of champagne. And so they sat there on the beach and had a little toast and celebrated surviving Hurricane Hazel. And then, unfortunately, they were divorced a few years after that. All right, so on to some other ones. Expect variation within each season. And I put this in because there's a lot that we could talk about on this. But I think the main point is to understand, as you understand the climatology of hurricanes, there's some interesting things that happen within a season. I'm guessing most of you have heard the term the Cape Verde hurricanes. The Cape Verde storms are the ones that typically form off the African coast. They tend to be some of the most powerful storms. They tend to be the ones that, like a Hurricane Andrew or a Floyd, that have been they've been brewing for days out in the open Atlantic, and they've come a long way when they finally reach the U.S. mainland. Well, the Cape Verde hurricanes generally occur during the peak parts of the hurricane season, which would be from somewhere around late August until maybe late September. So that's a time period when we can expect that type of storm. But interestingly, most of the hurricanes that form during the early part of the season, say June and July and early August, or the latter part of the season from October into November, those storms typically don't form off the African coast. They form a little farther deep into the Caribbean, and as a result, some of the impacts are different. A lot of our East Coast storms, like the ones that hit the North Carolina coast and the East Coast of Florida, unfortunately, very often those are the Cape Verde hurricanes. And very often some of the ones coming into the Gulf and the West Coast of Florida have been coming up during the latter months in October, for example. And so you see a lot of activity on the West Coast of Florida from October and November hurricanes. So there are all kinds of ways you can look at how the data might tell itself, but it's as you start studying the trends, it's just one of those things that's worth noting, that not all hurricanes come from the same area at the same time of year in the same way. And that's actually another corollary too, is that someone asked me once what was the single most interesting or most impressive thing about all the hurricanes that I've studied, and the conclusion I came to was the best answer is that no two are alike. Each storm we get, it seems, has its own unique characteristics and flavor, if you will, because some storms are large, some are small, some are fast, some are slow, some are powerful, some are weak, Some are wet, some are dry. I mean, there's so many variables that as we look at from one storm to the next, it's very difficult to compare. It's not easy, for example, to compare Hurricane Andrew, which was a small, tightly wound, super powerful, compact Cat 5 striking South Florida, to Hurricane Sandy, which was, really not a powerful storm on the Saffir-Simpson scale, but it was over 1,000 miles in diameter. So as we try to think about our hurricane threat, it would be a mistake for us to lump them all together as the same kind of storm event. So again, we're looking at variations all throughout the year, and it can be wind, it can be tide, it can be rain, it can be a lot of different factors when it comes to the hurricane damage that's affecting various areas. Number 7 seems obvious, but I've included it anyway, and that is our vulnerability is increasing. In a moment, I'm going to talk just a little bit about climate change and a relationship here. But let me start just by saying that, we live in a world now where climate change is a serious consideration, and it's a topic that you hear in just about every conversation now with hurricanes. When I first began doing my research and when I began working on these hurricane books, there really wasn't talk of climate change. That changed, I think, largely due to people like Al Gore, who produced the movie. I love this cartoon, by the way. He produced a movie which really got a lot of attention. But it also, I think it woke up a new element of hurricane research and understanding, and that is the relationship between climate change, sea level rise, and our hurricane threat. And one of the things I want to go back to when we talk about our vulnerability is that many times I've been asked, and reporters will ask me and others, aren't we seeing more hurricanes? Aren't we receiving more hurricanes than we used to because of climate change? And I think the real answer to that is no. There's certainly no evidence to support that hurricane frequency has been increasing directly as a result of climate change. And Mr. Lancey, Dr. Lancey down at the Hurricane Center, he gave a very interesting interview after Katrina, in which he kind of put some context on it. And I like to kind of paraphrase what he said. He said, Hurricane Katrina was a powerful storm, but we've had other powerful storms. And Hurricane Katrina's winds and tides seem off the charts, but really in this day and age, it's about what we expect from a storm like this. We've had other storms like this, and we will have more in the future. But is climate change a factor? And he said, yes, it is. And here's how it's probably a factor. The warmer sea temperatures in the Gulf of Mexico during 2005 certainly had given a jolt to the storms that moved through that particular year. And he described it as maybe adding 3 to 5 miles per hour to a particular storm like Katrina. So does 3 to 5 miles per hour of intensity, does that make Katrina the great disaster that it was? No, probably not. It would have been a great disaster had there not been that elevated sea surface temperature. So it's something I think is important for us to keep in perspective. The reasons for our vulnerability increasing has more to do with human behavior than it does with climate change, in my personal opinion. And that is, of course, the growth of our coastal population and the amount of property and people that live in harm's way. That is a trend that we see no turnaround on. We don't see fewer people moving to our coastal counties in the U.S. We see more people moving to our coastal counties. We see more homes and shopping centers and development being constructed in not only in Florida and North Carolina, but all around the hurricane zone. So we can understand that as time goes by, other great storms will come. We will rebuild. Now, there are lots of mitigating factors, though, and that's one of the things that's the good news. Good news is that newer structures that have been built in the last 30 years are built to a much standard than those from previous times when building codes were not as good as they are today, and other factors. So there's a lot of great work going on to make our communities more resilient, and that's the challenge, is to try to keep our vulnerability in check. The next point is always expect the unexpected. And gosh, we could spend all night sharing examples of how this plays, because with each storm, right when we think we understand what's going on, suddenly, particularly those who are directly involved, emergency management, government officials, local, state, and federal folks who try to keep us safe, there's so many things that can happen that we just don't expect. And I want to go back to the point of frequency when we were talking about some parts of the coast perhaps being more vulnerable or seeing more activity than others. I know Hal mentioned the southwest coast of Florida not having the storm tide events that you might find, say, on the east coast. And the same is true with other parts of the Gulf and the east coast of the U.S. One of the storms I like to use as an example was a hurricane in 1893. 1893 was a bad year for hurricanes. There were over 4,000 deaths in the U.S., and one of those was a hurricane that made landfall on the Georgia coast. And it's a little almost off the map here. This is actually not a very good graphic for it. But it's up here in the right-hand corner. You can see one of the two storms that moved up that way. Well, that particular storm was devastating in southeastern Georgia. And if those of you familiar with the Georgia coast, you may know that Georgia does not have an extensive coastline. And you may also know that Georgia does not have a real deep history in hurricanes. We don't have, the Katrinas and the Sandys and the Andrews to talk about, but we do have the 1893 storm to talk about, because it was probably a Category 4. I've read accounts that said it was a Category 3 and others that said it was a Category 4. But we know that it was a powerful storm, and it affected changed really the communities of the Georgia coast for many generations. But what's happened is that no one is alive today that remembers the storm of 1893. Generations pass, time goes by, people forget, and so suddenly now you can go to the coast of Georgia today, and you'll have people, even older people, who'll say, oh no, we just don't get hurricanes here. We haven't had one. Maybe a long time ago we did, but I always like to point back to the storm of 1893. This particular storm striking the Alligator Reef Lighthouse, this is one of those head-scratching things here. This lighthouse was hit by a pretty powerful storm. I believe this was 1906, and it damaged the lighthouse, and oddly, the glass lens from the lighthouse was found on a beach 8 miles away. You never know what you're going to expect. The same storm, hurricane, also had a great impact, again, miles from the coast. It was a rainstorm that swept through the Tennessee Valley after the storm made its second landfall, that caused flash flooding that washed out a trestle that caused one of the greatest train wrecks in U.S. history on the Cumberland River in Tennessee. And you might think, well, that seems like that's not really very related, but of course it is, because it was the heavy rains that washed out the trestle that these folks didn't expect to happen to them many, many miles from where the storm made landfall. And then another one of those odd little stories about what to expect is Project Cirrus. Back in the right after World War II, in the 1940s, there was a group of folks that got together with General Electric, I believe, and the U.S. Air Force and the U.S. Army, and they were researching the possibility of seeding hurricanes. You've probably heard of this before, the idea of flying into a hurricane, dropping canisters that contain various chemicals to try to force the hurricanes to rain themselves out. And there's a lot of lab research work done on this during the 40s, and they really thought that they were onto something, that their experiments had paid off in the laboratory. And they finally convinced the federal government to let them do a test, a live test. So in October of 1947, they were looking for a hurricane that might serve their purposes to do a test. And they thought they had found just the right hurricane. This was a storm that came ashore on the southwestern coast of Florida in late October, and it ventured out into the Atlantic. So the flight left from Tampa. They flew into the storm. They dropped several canisters, I believe it might have been silver nitrate, and exposed that into the storm to see what would happen. And unfortunately, probably coincidentally, the storm made an abrupt stop, turned, came back, struck Savannah, and killed 2 people. So Project Cirrus was canned. All right, so we're almost done here. The last couple I've got, forecasting and warning, have come a long way. And
Just so you know, Jay, every time you tell the stories, everybody laughs. We're muted. We've been laughing our butts off.
Well,
really...
I'm glad to hear that. I'm glad to hear that, Karen, because no one's laughing here but me. So
no, we're laughing. We're laughing every time we're trying to unmute.
But these stories do have that. I mean, they're worth telling for those reasons. But I'm hoping that there's a point attached to some of the humor. So, so forecasting and warning have come a long way, and I think that's again an obvious statement. We know that. But I think it's also, looking at our history of hurricanes, it's a good idea to look at the history of what's happened with forecasting as well. But I will tell you the real reason why we keep getting so many hurricanes. It's all because of this man. And every time he shows up, it seems like hurricanes tend to come ashore, and there's lots of problems. So I like to really give him a really hard time. Everybody, please send him an email and ask him to stop. So our history in forecasting is so recent. That's what's struck me as I got into this. The National Hurricane Center, of course, didn't exist until the mid to late 1950s. Prior to that, all of our forecasting was done by the U.S. Weather Bureau out of their Miami office. Even prior to that, was done out of Washington, D.C. If you've ever read Isaac Storm, by the way, Isaac Storm, Hal mentioned earlier the Galveston hurricane, a great account. Highly recommend.
We have like 10 copies right here in the.
Okay, good. Well, you'll get a real dose of the bureaucracy of 1890 and 100 from that book, but some of the anecdotal things about our understanding of hurricanes is interesting. One of which was that during the 1930s, this was what a hurricane warning looked like. It was they were actually pasteboard boxes dropped by the Coast Guard along the southern coast. This was in the Keys, along the southwestern coast of Florida and down in the Keys. So this was a hurricane warning dropped from an airplane in the days prior to an advancing storm. But how did we know a storm was coming? It wasn't because we could see it. It wasn't because we knew exactly where it was. It's because we thought we knew where it might be. That's a very different story, and that was all the way up through the 1940s, by the way. Now, here's a gentleman that you might not know about, but he probably deserves as much credit as anyone for modern hurricane meteorology. Father Benito Vines was Havana, 1800s, and he established the first hurricane warning system that was ever put in place. And the way it worked was he had weather monitoring stations around the coast of Cuba, and he's established essentially a Pony Express route across Cuba, where when hurricane conditions or information was conveyed to one of the spotters, a gentleman would jump on a horse, ride across the nation all the way back to Havana and report the status of the storm, and then that would then be distributed by horseback to some of the other places in harm's way. So it was the very first hurricane warning system. And President McKinley actually was quite impressed by this system. And as the hurricane, as the Weather Bureau began looking at what to do, how to deal with these devastating hurricanes, particularly after the 1900 storm, this was a system that was considered really a model. And a lot of what we think about today and getting the word out began with Father Vines. Now, what you're looking at here is a photograph. This is from Life magazine, and this is Grady Norton standing on the left. Grady was the senior Weather Bureau forecaster in the Miami office through the 1930s, 40s, and 50s. He was considered the greatest forecaster in the Weather Bureau. He was in Miami, and it was his sole responsibility to forecast these storms as they would approach. And by forecast, what I mean is, again, more of an art than a science. Take the ship reports, whatever information might have been available by radar, which of course didn't come along until the late 1940s. And he would compile all this information, and he would craft a forecast. And if you read some of his old forecasts, a lot of times they were not very specific. They would talk in generalities, but they would still be helpful to a entire region, or maybe that could be put on alert so that preparations could be made. Now, in 1954, Hurricane Hazel, I mentioned earlier, was on its way to the U.S. Hazel struck Haiti and was devastating. It was, I believe I've read before, over 1,000 lives were lost on that island nation due to Hurricane Hazel, mostly due to flash flooding. Just a devastating effect there. And Grady Norton had been tracking ship reports all throughout the Caribbean, following Hazel's every move, hour by hour. He'd been working around the clock, working 18, 20-hour days, sleeping at his desk and so forth. Well, unfortunately, the morning after Hurricane Hazel passed over Haiti, just as it was making its turn to head towards the U.S., Grady Norton had a stroke and died. And the young man sitting at his desk was his intern, who then was drafted into responsibility to complete the forecast warnings for Hurricane Hazel up the U.S. East Coast. So it just gives you, I think, when you hear this story, it makes you realize how far we've come with our abilities, with the National Hurricane Center's capabilities, with their planes, with their radar, with their satellite, and with their supercomputer modeling. That we have the luxury today to look out 5-7 days and see where the storm is, know how big it is, and pretty much have an idea of where it's going. I mean, the forecast error, yeah, it's not perfect, but it is getting better all the time. And what a relief it is that we no longer have to live in fear of the storm that might surprise us. But that was not always been the case. And a lot of the compelling stories in my book deal with that very topic of people who just really didn't have enough warning to get away from the coast or to evacuate their families before the storm struck. And I should add that the satellite age, of course, is the single most important advancement in our understanding and our ability to monitor hurricane activity. Where would we be if we didn't have images like this to send back to people on CNN or the Weather Channel or the internet, so you really know what's going on and you get to see it. That's again a very recent thing, and we really should be grateful. Sometimes we bash our weather forecasters, especially when the local channel goes wall to wall 24/7 hurricane. We get tired and we get jaded, and we don't really like to hear it so much. But it's really saved a lot of lives over the last few decades. It's an interesting communication example. 1995 Hurricane Opal. Some of you might remember Opal was a Category 3 that stormed through the Gulf of Mexico and had an interesting track. It really was, in many ways, it was a forecaster's worst nightmare. On October 3rd, it began a rapid overnight intensification and acceleration. Those are the two worst things. That's the two things that a forecaster does not want to hear: that the storm is intensifying before landfall, that it's accelerating before landfall, and that it happens during the nighttime hours. That's just a recipe for disaster. So this storm went from a Cat 1 to a Cat 4 in 36 hours. Well, the evacuation process, some people had taken the warning and started to evacuate well before. But, as a Category 1 is approaching, I just have to say that most of the U.S. population doesn't seem to be compelled to jump in their cars and run from a Cat 1. It does happen in some areas, but in a lot of places they just don't do it. Well, this particular night, it's a very interesting one because the storm's rapid intensification occurred after dinner time. So people had already had their dinner, and some people had already gone to bed. But some were staying up to watch the 11 o'clock news, and they were waiting for the latest update, and they waited. And unfortunately, the information about the intensification of this particular storm, it didn't happen at 11 o'clock. It didn't happen at 11:01 or 11:02. They didn't even start talking about the hurricane until about 11:16. Well, that was too late for some people. They had gone to bed. And the reason for the delay was that happened to be the night of the O.J. Simpson verdict. And so all the network's news coverage was dwelling so much on the verdict from the O.J. Simpson trial that the hurricane evacuation notice didn't get the play that it should have gotten. So there are all kinds of ways in which we remain vulnerable, even when we have the information sometimes that we need. All right, I'm getting close to the end here. I'm going to sort of wrap up by talking about what the future holds. And surprise, surprise, more great storms will come. And how do we know that? Well, it seems to be obvious. If you look at this, is just North Carolina in the last 15 years. We've had our share of storms that either made landfall here or had a significant impact here. I want to use an example. One of the examples I want to use for this is Tampa. And I know earlier we had Hal was talking about flooding in Tampa Bay and the storm surge occurrence there. I'm getting a lot of feedback all of a sudden. Karen, can you hear me okay?
No, something happened. There's something wrong.
Here, try the keyboard, use that.
I can't do
it.
Sounds like something ringing.
Yeah, it's saying that there's an incoming call, but I can't click ignore.
Push the voicemail. There it goes.
All right, we're good. Keep going.
Okay. All right.
There's something weird here. I don't know what it is. The smart board.
The smart board's acting.
All right.
We're good. Keep going.
All right. Well, I'll pick back up where I was. I just want to talk about Tampa for a moment, because when we talk about the fact that more storms will come, there's probably no place in the country that needs to hear this message more so than Tampa Bay in that region. And some of the reasons are pretty obvious. If you look back at some of the milestone events in Tampa, you go back to 1848. Hal, I don't know if this one is in your database, but we have record of a 14-foot storm surge at Fort Brooke. Fort Brooke was, of course, there before there was a Tampa, but it was, you see the location there in Tampa Bay. 14-foot storm surge, which pretty much devastated the fort, the Army, all the Army installations there. And it was a long time ago, 1848. And then the next significant event was in 1921, where once again we had a Cat 3 come into the Tampa area, made landfall, straight into Tampa, through Tampa Bay. One of the interesting things that happened during this was that there was a rumor of thousands of people that had died, but that really wasn't the case. It really didn't kill a lot of people, but there were a few fatalities. But I think the point is that these storms were, again, they were so long ago. 1921, we're coming up on almost 100 years since Tampa has received a major hurricane landfall. That's a long time. And you couple that with the population in Tampa, the way the population is distributed, the evacuation situation with the various highways throughout the Tampa-St. Pete region. And what you have really, people always talk about New Orleans as being recipe for disaster. Well, I would argue that Tampa may be even more so. For one thing, you know, with New Orleans, they've suffered through it. They've suffered through it more than once just in the last 60 years. In Tampa, there's entire generations have grown up not understanding hurricanes, truly understanding them, and not really thinking that they're vulnerable. So I want us to always keep that in mind. Some areas that get hit more frequently tend to be better prepared and more accepting of that risk. The Galveston hurricane, there's so many great storms that we tend to focus on that like the Galveston storm or Andrew in 1992 in South Florida, Katrina, and Sandy. You hear about all these big ones. A lot of times, from my research, very often some of the greatest destruction occurs from some storms. It may not be the peak storm. It might not be the Cat 5. It might be a Cat 3. But the Cat 3 is devastating for a particular area that hasn't seen one in, say, 50 years. So it doesn't have to be an off-the-charts, blockbuster, devastating storm. And actually, Sandy is a good example of that, because Sandy was not nearly as powerful as the other ones that were listed just now. The Miami hurricane in 1926 is one I want to come back to for a second. I talked earlier about Chris Lancy and his normalization process, where he takes a look at historical hurricanes, and he goes back and recomputes their dollar impact in today's dollars and in today's times. So what does that mean? It means he looks at if the 1926 hurricane, or you pick any storm you want to look back on, if it were to happen today, what would the dollar impact be? And the last time I saw his list, this Miami hurricane in 1926 was at the top. And it was close to a $200 billion hurricane. So what he's saying is that if we were to get a hurricane just like the Miami hurricane of 1926, the Cat 4 that makes landfall in downtown Miami, crosses the Florida Peninsula, strikes again in Louisiana in much the way the Miami hurricane did, then we could be looking at a storm that far exceeds Hurricane Katrina, which is currently the most costly hurricane disaster in U.S. history. So it's one of those things that we can expect at some point in the future. We're going to get another Cat 4 on the southeast Florida coast. Will it be south of Miami like Andrew? Will it be above like the Okeechobee storm in 1928? Somewhere in the southeast Florida region where you are today, there will be another Cat 4. We just don't know when it's going to be. Dollar impacts from that storm will be, again, looking at his charts, they're going to be extreme. We're going to be looking at more of these multi-billion-dollar disasters. And I guess at some point, the economists sort of weigh in with their thoughts about what our communities can withstand. Can the insurance company, can the insurance industry withstand a series of these? The insurance industry has been taxed by Sandy and Katrina to the point where many insurers have pulled out of some of these more vulnerable areas, and it's very difficult now for homeowners to even get insurance. That may be the case with you, Hal, on the coast of Texas as well. So there are all kinds of twisted economic nasty things that we can unfortunately look forward to as we continue to see these multi-billion-dollar hurricane disasters roll through. So just wanted to keep that in mind. And if you go to the National Hurricane Center website, it might actually be the Hurricane Research Center site where Chris keeps all of his database of historical storms. You can find that normalized dollar list, and he updates it every year, and I haven't seen it recently, but those dollar figures are not going down. They're going to continue going up. So just to wrap up, I want to caution everybody to have a good hurricane evacuation plan. Know what you're going to take with you, know where you're going to go, know the kinds of risks that you might face if you don't go, and also be prepared for how long you might be there, because some of the evacuees from some of our storms, they're not displaced for 3 or 4 days. They're going and staying weeks with friends and relatives or in hotels or wherever they might be able to find. It all depends on your situation and your location, the severity of the storm, lots and lots of different factors.
Jay, I'm so sorry to interrupt you. This is Hal here. Was that last slide an example of a good evacuation plan or a bad one? Because I saw that there quite a few beverages
That's probably not the best evacuation plan, but it's probably not too different than
not the worst either.
Yeah, it's probably not too different than my own, actually.
I think maybe that orange bottle is sunscreen, so that's good.
Yeah, that's good. And there's some Band-Aids, I think I see too.
Yeah, Band-Aids.
All right. So that's my last one, Karen, and be happy to either have some dialogue or answer some questions.
Yeah, this was absolutely incredible. You guys are amazing. This is like amazing. You guys are just you blew it out of the park. Really awesome. Thank you so much. I'm sure we have tons of questions. Come on, Will. No question?
How? One of your slides there, you showed, I think it was all like the storm surge data from like the 1900s up until more current times. And it seemed like the majority of those events were from more of the current time period. Do you have any reasons for that?
Yeah, great question. Really, the main reason why we see that at a local location is I think that might have been, those were data, I think, from South Padre Island, and I think they have a tide gauge that's been working there since maybe 1995. So here's the thing, if you go back far enough in history to say 1903, if there was a 3-foot storm surge, that really didn't cause any damage, so it wasn't really recorded and passed down. So when you go back to the late 1800s, early 1900s, if something was big enough to cause some damage, you know, a 10, 15-foot surge, it would have been recorded and passed down. But if it was a small surge, it just kind of went unrecorded. And so, but in the tide gauge era, if a place has tide gauge data for the last 20 years, if something's only 1.5 feet or something, we record that. Another thing, Jay, you mentioned about like Jim Cantori and, you know, but I mean, it's kind of humorous, but I wanted to ask you, it seems to me that what I found in the literature, when I go back to say the early 1900s, it seems like a lot of the newspapers and local media, it seems to me like they really try to downplay the storms. I recall, I think it was a 1933 storm in South Texas. The local paper said the hurricane that was predicted here really never happened. And then later, farther down, they're talking about mattresses and chairs thrown around the beach. And I'm thinking, wait, so the storm surge was high enough to go into houses, rip out the walls, you know, drag furniture down the beach. And their response to that was, oh, it never really panned out to be that much of a storm. I think my take on that is the local media really didn't want to scare away tourists and investors. Whereas now we'd have the Weather Channel there. I mean, if you had a 2-foot storm surge, it'd be out there in the surf. And it maybe seems like everything's recorded now, almost over-recorded sometimes. I don't know what your thoughts or if you've seen that as well.
I think, Hal, that you're exactly right. And there's probably not a better example than what we saw in South Florida in the 1920s, because land speculation was at a fever pitch when the storm came through. And there were a lot of mostly northern investors who stood to lose everything because they were counting on droves of people moving to South Florida to buy their homes and properties, so they did very strongly tried to stop those stories from getting out. And the Red Cross is actually credited with shining some light on this. They launched the first ever national disaster relief effort after the 1926 storm. If it hadn't been for the Red Cross, most people across the nation would never have heard of this hurricane and its impact. So you're right. There's certainly a cover-up brewing in that particular event.
I do know that still exists to a small extent with local governments. Sometimes local governments, I've seen along the Gulf Coast, they don't want some of those high water marks out there scaring away investors, or, you know, so that still does exist to a smaller extent, I think, today.
Yeah, I think some of the high water markers that I know about in our area have all been stolen. So they don't last very long, it seems.
I've heard stories about Andrew. There's a professor here at FAU that thinks there's a conspiracy and that there were like piles of bodies floating in the canals after Andrew. A lot of people think there was a huge death toll that was covered up from Andrew.
There were a lot more deaths in the report. If you were out there on the field, you would have seen it. Like, I had family who was out there and they responded as part of the Red Cross effort. And the totals that she saw and the totals that were reported were not quite the same. So there's probably.
Can you guys hear that?
Could you repeat it?
Oh, that I had family that was actually responded to Andrew, to that whole disaster effort. And they saw a lot more bodies than what were reported. There were a lot more injuries than that actually reported. So that's interesting. So there might be kind of a cover-up. But not conspiracy per se, but.
It is interesting, and it's actually surprising in the modern age. It would not be surprising at all to go back a few more decades and have that kind of thing happen. But I know that undocumented workers, for example, many times after a hurricane disaster, people scatter, and you might never see that person again, and it's hard to know whether they're missing, whether they've moved somewhere else, or whether they might be deceased.
Okay. You know what I was thinking about? I love about how you spoke, Jay. I mean, I loved everything. The stories were so cool. But when you kept talking about insurance and economics, and that's actually our topic next week. So I was excited to kind of, look into it. And I've been I'm confused about the whole insurance thing because you have, your private, you have your homeowner's insurance, and then you have, and that's for wind. But then you have your flood insurance from the National Flood Insurance Program, and that's for water. And then, comparing, there's this, and what we have in South Florida is we have most of the storms have been windstorms. We haven't had Andrew had a big surge, but only in this small area. So it just makes me wonder when you compare, we really, my point is not good. We've really kind of, I think in terms of our building code in South Florida, we've really adapted to wind and not water. And it's a really big problem because from an engineering perspective, I mean, when you look at the equation for force, the density of the material is cubed. So
That's right.
The force of air compared to the force of water is like, it knocks it out of the park. I mean, water has so much more force than wind, and surge is just not a big issue down here, and it's going to start to be one. And I mean, I think we've changed our codes and we've built for wind, but not for water. And then there's there's that issue of the actual force, but there's also the issue of, for insurance purposes, is it wind? How do you even tease out wind damage versus water damage when it's just about, okay, it got wet, that's water damage. What about, it
floated away.
Yeah.
Yeah, there are a lot of stories about your very question. In fact, I know down after Katrina, there was a lot of angst and congressional investigations and other things about the insurance process in that recovery, because most of those homes got it both. They got the high winds and the flooding. And the National Flood Insurance Program, of course, covers only rising water, doesn't cover rainwater that's falling from the sky. So there are all kinds of variables that have to be considered. But you're right, South Florida has the best building codes in the U.S. for hurricane resistance. The wind rating for your windows and your walls and your roofs are stronger, at least in Broward and Dade County, than they are in other parts of the U.S. And that's a good thing. And it's probably warranted because some of our highest winds ever recorded in the U.S. have been in those counties. So that's probably it's a smart move on your part. In terms of insurance, one of the misnomers about, and I do a lot of speaking to senior groups and others, and they're always, you know, asking questions about insurance. And one of the things that that is not a very well-known fact, people will say to me, why should my federal tax dollars through the National Flood Insurance Program be subsidizing those millionaires' homes out there on the beach? That's just not right. And, you know, maybe they have a little bit of an argument, but the reality is that the vast majority of payouts for national flood insurance claims aren't even related to hurricanes. They're all across the Midwest, and from California to Minnesota to Iowa, but they do include coastal storms as well. So it's not quite as it's often perceived with regard to national flood insurance.
Karen, a follow-up with that as well. I know in Louisiana there was extensive litigation after Katrina. You'd find a house with part of the roof blown off and a lot of flood damage, and really trying to reconstruct, was it more likely that the wind damage happened first, or that, you know, and then rainwater came in, or that the storm surge got there before? There was a lot of litigation related to trying to piece that together depending which neighborhood you lived in.
Oh my goodness. So, wow, that's so interesting. Yeah, I think it's going to be a huge issue, because I think people, like down here, people just have no idea about surge. And when we get that high surge, you know, luckily we have a very steep slope offshore. So even the highest surges for Fort Lauderdale, downtown Miami, Miami Beach are 10 feet. It's not terrible.
Karen, your slope off of the Miami coast, you described it as a steep slope?
Yeah.
Okay. It's interesting, because there have been some sizable surges right through that region. And I don't know how you probably have the better date on this, but I think Andrew was about 16?
Well, that was, yeah, but that was much further south.
Oh, okay.
Talking about north of there. Yeah, there's higher surges going south towards Key Biscayne, south of there. But I'm talking about downtown Miami, Miami Beach, Fort Lauderdale, those areas, the maximum is 10. And for Andrew, actually, Hal and I have been working together on a project, and he has been so helpful. I'm doing a project for a transportation study that actually looks at Andrew and delineates like wet versus dry land for Andrew, and then it's going to be, we didn't choose the next scenario, but it's going to be the same if Andrew hit, you know, probably 2040 with sea level rise, how much more area will be wet, and they're putting it into a transportation model to figure out what's going to change with the disruptions. But what was really cool is that I have the slosh model, and I have the data from there, and the slosh model shows that Andrew didn't get higher than 10 feet. But then Hal was able to give me the observations, and he gave me 30 different points. And so I don't know if anyone's ever done this before, but I call it data fusion, where I adapted the slosh model with the points that Hal gave me, and I think it's a much better depiction of Andrew. And then I'm going to add sea level rise next. So thank you, Hal.
I'm glad you mentioned that. That's been a fun project, but models are so important that we'll need them always. But sometimes we see the fancy animations and graphics, and we just assume it must be right, you know? And this was a really interesting example where it looked like slosh, which is, I mean, that's the model that the Hurricane Center uses to predict storm surge levels. It looks like when we compare that to observed data, that slosh pretty well underpredicted, you know? So it's always important in science, if you can validate something with observations, it's a good thing, you know? And in this case, it looks like maybe we could really improve the results by incorporating observed data.
And the other thing is what I was saying earlier about how no two storms are alike. You know, I'm sure that there's probably a lot of data that came out of the Hurricane Sandy event that could easily be compared to the slosh model data that was presented beforehand, so that they could go back and do an analysis. But Sandy, again, was such an unusual storm that my guess is they probably wouldn't adjust their models based on that particular event, because it was such a gigantic storm in terms of diameter and that's a different type of hurricane almost than a typical hurricane, which has about a 300-mile diameter.
Yeah.
Well, the thing about the slosh is that they have this one, the most widely used is the maximum of maximums. So they run tens of thousands of storms from all different directions, all different wind speed, like they changed all the different variables. And so the slosh, it's a grid of cells, and each cell, I mean, they're big, they're like half a mile, but each one has a value. So for all of the tens of thousands, for that one little grid cell, for all the tens and thousands of storms, the highest possible value is the value that's assigned to that cell. So even with the maximum maximums, you have something similar to Andrew, where the highest surges are in the same area where Andrew had the highest surge. Does that make sense?
That's a good point, Karen. A lot of times these patterns, I call it pattern recognition, and it's fascinating. Observed data is important, but there's a limit to its usefulness because, as Jay's saying, every storm's different. So we may have a hurricane this year, and it may be very different, the track of it, the intensity, the forward speed. It won't be exactly the same as anything we've seen before. So that's why we need modeling. That said, though, what we've seen with some of these observation, like when we can build these massive observation data sets, we'll see in a given area a certain, like for example, near New York City, just to the east of New York City is an island called Long Island. And between Long Island and Connecticut, there's a narrow body of water called Long Island Sound. And when you start looking at the historical data, winds from the east will tend to push storm surge, and really have a maximum at the southwest part of that sound, kind of down by the Bronx. Now, if you're a Red Sox fan, you're like, hey, that's going to flood Yankee Stadium. Let it go. I don't care. But if you're a Yankees fan or a good U.S. citizen, you'll say, hey, we need to save New York City, and we need to be aware of these patterns that tend to repeat. And so that's the advantage as well of knowing your area, of looking at observed data, looking at models. You can start to see certain areas will tend to repeatedly have higher water than other areas, and that can help with planning and zoning and things like
that. I had one curious question. I think it was you, Jay, who mentioned the Mayan word for their hurricane god. For their storm god. How do you spell that?
I have to look it up. Hurricane. I think it's something like Hurrikan.
Okay, because that's actually how we spell hurricane in Spanish.
Oh.
So that's why I was like, oh, that's interesting. But that's all from that region.
Yep. It's from the Maya.
Go figure.
I have a question for Hal.
That's Jose, by the way.
From the sections that we read, and I generated a question pretty much like, or at least a suggestion. And I wanted to ask you, and that is, have you thought or have you started any particular research on the lag between the wind speed change? For instance, when Katrina made landfall, it was a Cat 3, but before that it was a Cat 5. But then during the landfall, it managed to produce 28 feet of surge. So I guess the question is, have you thought about doing research on the lag between the wind speed change of a storm and the generated storm surge, or no?
Yeah, that's a great question. Actually, when I was a PhD student, I did a lot of research on that, and I actually published a paper it was in Earth Interactions journal. And what I actually found is the storm surge heights correlate much better with the pre-landfall winds than they do with the winds at landfall. So Katrina, for example, makes landfall as a Cat 3, but it produces the highest storm surge in the history of the Western Hemisphere. So a lot of people said, well, how could that happen? It actually produced a higher storm surge than Hurricane Camille, which made landfall in the same area as a Cat 5 hurricane. So how can a Cat 3 produce a higher storm surge than a Cat 5? Some papers came out around 2007, 8 that said, really, we underestimated the role of size. And that's true. that Katrina was a very large hurricane, which is true. But many of these papers continue to call Camille a Cat 5 and Katrina a Cat 3. When you go offshore 18 hours before landfall, Katrina and Camille were comparable. I mean, the wind speed was only about 11 knots different, or about 15 miles an hour different. So Katrina, pre-landfall, it was very large, but the wind speeds were about 175 miles an hour 18 hours before landfall. So this study that we did, we correlated storm surge heights with the hurricane wind at landfall and at 3-hour increments before, and we found the pre-landfall winds correlate much better. So that would be a concern if you see a Cat 4 or Cat 5 out in the open water and then it's weakening as it's approaching the coast, especially if you're in an area with shallow bathymetry offshore. You might not have a lot of wind damage, but you would get most likely a very sizable surge. And the opposite's true as well. If, like Hurricane Charlie in 2004, it was very small and it didn't hit an area with very shallow bathymetry, but when Charlie hit down by Naples and Fort Myers, it was rapidly strengthening. And so it made landfall as a Cat 4, but the surge was only about 7 feet. So again, I think we found scientifically that there's a correlation really between those factors that you mentioned.
And Hal, if I can add that in North Carolina in 2003, Hurricane Isabel is a perfect example of what you've just described. I don't know if that's one of the storms you might have looked at, but Isabel was a Cat 5 over the Bahamas. It turned and weakened and was barely Cat 2 at landfall in North Carolina. But here on our coast, we saw some extremely high tides, much higher than you would ever expect from a Cat 2 in our region.
Yeah. And in 2008, after Hurricane Ike, the National Hurricane Center officially dissociated these categories of storms from the storm surge height because, you know, the public, when they hear Cat 1, it sounds like, oh, it's not that bad. Sandy was a Cat 1. Isaac in 2012 was a Cat 1. But again, you know, they could have a huge storm surge. Hey, I'm hoping we can interact a little more. I had 3 really quick bullet points just to share with you guys. Jay, I wanted to thank you personally. This is really cool to interact with you. For our storm surge database, I think you were one of the first authors whose work I found. And the coolest thing, it was very scientific, but it felt like I was reading a novel. You had a good way to bring the science in accurately, but really hold interest. So I'd strongly recommend if you pick up either Jay's Florida's Hurricanes History or North Carolina's Hurricanes Histories. Really cool stuff. It's scientific, but it kind of reads like a novel. It's really interesting. And 2 last things I wanted to mention. I'd like to encourage you guys. I wanted to go to grad school when I was 22, and I ended up living in Africa for a few years and traveling around. And I never really got into grad school until I was 30. But along the way, I talked to a lot of people that were professors or doctors or grad students. And one consistent message I heard was to take a topic that really matters. I'm from Pennsylvania. I'm a snow and ice guy. I get really excited by 20 below and snowstorms. And I never really was a tropical guy, but a few different scientists said, hey, this storm surge, you know, when we think about Katrina and Sandy and all these events, the big tsunamis like in Japan and in Indonesia, I mean, look at some of those graphs that Jay put up there. We're talking hundreds of billions of dollars. When you have that amount of losses, there will be a lot of opportunities to get funding to do research and work. And I have absolutely no regrets. I mean, I came to Louisiana. I didn't know a whole lot about storm surges and hurricanes, but I quickly learned. And, you know, you might be from an area where you didn't grow up around hurricanes, but that doesn't mean you can't research some of these topics. And the last thing, Jay, you were spot on when you said, you know, if we don't learn from history, we're bound to repeat its mistakes. It was kind of cool for me to put those Galveston pictures on now that I live there. And I actually showed you guys like, oh, my house is there in the debris field. I do need to preface that with the island was actually raised about 16 feet. And the Galvestonians built a massive seawall that extends a couple miles. It's a 17-foot seawall. So right now, we still can get storm surge coming from the back of the bay. I refused. I was just here 2 weeks ago looking for housing, and some landlord said, oh, you can take the ground level. It doesn't flood much. I absolutely refused. I would have lived in a tree before I would have rented something on the ground, because some of those graphs I showed you guys, even people that say, oh, I've been here 30 years, Ike was an unusual thing. I think a lot of these coastal locations are really underestimating their flood risk. So I just rented an apartment that's like 12 feet elevated, and this area is protected behind the seawall. So that's something to think about when you travel, when you live someplace or even do business. Be aware of natural hazards, whether it's earthquakes or hurricanes. But I wanted to preface that because I showed I'm living in the debris field. Things have changed. We've made some adaptations, but I think my house is safe, but it's elevated as well. So anyway, I just wanted to clarify that. And I'm hoping we still have a few more minutes for some more interaction.
Yeah, I think we're going to wrap up, but I want to say that I had this thought when you guys keep mentioning storms of the term like name dropping. You guys are expert hurricane name droppers. Like usually name dropping is not a great thing, like, but you guys do it very wonderfully, and your expertise is just incredible. We're blown away. This was an amazing lecture. Thank you so much. I really, really appreciate it.
Thank you for the opportunity, Karen, and good luck to all the students.
Yeah, thank you so much, everybody.
Thank you.
Thanks for all the feedback. All right, well, we're going to go on a break.
Sounds great.
Will you guys send me the PowerPoint so I can post them in our lectures?
Yeah, absolutely. And I know for me, if any of the students want to send an email directly or whatever, I mean, go for it. I love interacting with students. So.
Yeah, I'll give them your email.
Yeah.
All right. Thank you.
Okay.
All right, thank you.
Good night, everybody.
Bye.
Actually, it's really nice.
Corey, are you like what's the
Yes.
or mouse cookie?
If you give him a list of money, he will ask you for a glass of
Please tell me somebody else has read this.
Yeah,
Okay.
He will ask for a glass of milk.
Yeah.
Yeah.
That's like, the best thing I've ever read.
Yeah, all right.
And
Great, 10 minutes. 8 times 8.